All right. So now I'm going to go back and share my screen. And there we are. We're in this ILM today, as you know, and we're talking about fractions. So I kind of jumped the gun a little bit, and I should have recorded before I even said anything, but that's just the way it is. So now we're talking about fractions. When we're adding fractions, we need a common denominator. When you're adding fractions, the denominator remains the same throughout, and we simply add the numerators together. Yes? So 2 over 2 reduced down is equal to 1. Pretty straightforward stuff. Yes? Okay, so but when we add fractions that don't have a common denominator, for example, if I added 1/4 and I added a half to it, in this case, we actually need a common denominator between these two. So I usually, what we do is end up going to the larger common denominator. So I'm going to change my 1/2 inch into quarters. And what I do is I know that if I simply times this by 2 and times this by 2, I will get my quarters. So that's going to be 1/4 plus 2/4. See, now this is equal to a 1/2. So this 1/2 is equal to 2/4. We know that. And if we add, we know that when we add fractions, the denominator remains the same. We add the numerators, and that's going to be 3/4. It's pretty straightforward. We have it. There's no rocket science yet. We're going to get to that in a bit. So that is just adding fractions, is getting a common denominator. Now, when we do subtracting fractions, for example, if I had 1/2 and I minused off 1/5, again, in this particular equation, we don't have common denominators. So we need a common denominator, and we'll go to the biggest one, but 2 doesn't go into 5. So what we end up doing is actually multiplying these together to get something common. So if I take 1/2 and I times this by 5 on the top and times it by 5, this is going to be 5/10 is my 1/2 inch. My 1/2 inch becomes 5/10. And now I could change this. I will take this and multiply it by 2, and this is going to be 2/10. And now I have a common denominator. It's pretty simple. The denominator goes through the equation. I take 5 minus 2, and that is 3/10. Pretty straightforward stuff, right? When we subtract. And I know some of this is a little boring, maybe not, maybe it's a little easy, but that's okay. We have to start somewhere. So now that's subtracting fractions, and I'm going to continue with subtracting fractions, and I'm going to do something a little more interesting. I'm going to say 1 1/4 minus 3/8. So now we have an issue. We have some bigger numbers. We have a whole number, and we have a fraction of a number, and we want to minus it. So we still need a common denominator between these two. And I'm going to go to the larger one. So I'm going to make my 1/4 inch into 8ths. And I simply times that by 2 and times that by 2. So that's going to come up 1 2/8 minus 3/8. Now, as you can see here, I cannot minus 2 minus 3. I'm going to get a negative number. So what I have to do is my whole number 1 is equal to 8 over 8. And I will make that all of a fraction. I'm going to add 2/8 to that. So I'm going to have 10/8. This is equal to this right here. 10/8 is equal to 1 2 over 8. And now I can minus 3/8 off of that. The denominator remains the same. And I could just take 10 minus 3, and that's 7/8. So if you have a chat and I can't either mixed fraction and proper fraction before I start. Okay, well, thank you for that, Kristen. We're going to get there. We're going to get there. Okay, so that is really minusing fractions or subtracting fractions. I'm going to just move over here a little bit, and I'm going to talk about multiplying fractions. So when we multiply fractions, let me just put an example up here, 3/5 times 1/2. When we multiply fractions, here's the rules for that. You actually multiply the numerators together, 3 times 1, and you multiply the denominators together, 5 times 2. And that's going to be 3/10 when you multiply fractions. It's pretty straightforward. Now let's do a little bit more here. If I say 1/4 times 1/2 times 3/8, it starts to get a little more hairier. So we multiply all the numerators together. 1 times 1 times 3 is equal to 3. 4 times 2 is 8 times 8 is 64. So when we multiply fractions together, the number gets smaller. Always. When you multiply a fraction, the numbers get smaller. When you multiply a decimal, it always gets smaller. So let's do something a little more crazy. Let's do some whole numbers with some fractions. So if I go 2 and 1/8 times 3/8, now we have an issue. We have all these dissimilar increments of measure sitting there. Jan, thank you for that. It's just the rules about multiplying fractions. You don't have to have a common denominator. You just have to multiply them through. It's just the way it is. So I don't know how to explain it otherwise, but thank you for that. Now listen, if you guys have a chat and I don't see it, you're gonna have to speak up. Hi, Bay, good morning, how are you? Thank you for joining the room. There's another chat. Oh, all right, thanks, Alex. Okay, so let's get back to this 2 1/8 and 3/8. And now what I can do here is I can convert my 2 into 8s. So 2 is equal to 16/8. You can see how that is equal to 2 inches. So I'm going to add one of these, this 1/8. So I'm going to add 1/8 to that. So 2 and 1/8 is equal to 17/8. And then I will simply multiply that by 3/8. So this is going to be a bigger number here. So 17 times 3 is 51. And then 8 times 8 is 64. So 2 1/8 times 3/8 ends up being 51/64. Crazy days. Okay, how's that so far? Pretty crazy stuff? All right, so that's multiplying fractions. Let's start talking about dividing fractions. So anytime you divide a fraction, your number gets bigger. For example, if I had 1/3 and I times it by 1/2, or excuse me, I want to divide here, don't I? Let me just change that. We want to divide, oh, come on, pen. We want to divide by that. So what happens when you divide fractions is the divisor becomes reciprocated, and we rewrite this as 1/3 times 2 over 1. So it's kind of a cross multiplication deal, what's going on. So this becomes reciprocal, and turns into 2 over 1. So then we multiply this through. 1 times 2 is 2. 3 times 1 is 3. So 1/3 divided by 1/2 ends up being 2/3. I think we'll try another one of those. So if we have a fraction, say 1/4, and we're going to divide by 1/5, what we do is we take the quarter and then we start multiplying the divider, but it has to be a reciprocal. So this is going to be 1 times 5, 4 times 1. That's 4 over 5. And when we have a fraction that looks like that, this is called an improper fraction. So we need to reduce that improper fraction down to its lowest terms. 4 goes into 5 once with a 1 remainder. 5 over 4 is equal to 1 1/4. Not too bad, okay? So the next portion of this that we probably should talk about, oh, I don't want to do that, is fractions into decimals. First, before I continue on, does anybody have any questions that you want to ask me or tell me or anything at any point?
Yeah,
Please.
just quickly. So if you add a third division on there, you would just take the reciprocal of that as well and divide through the initial one?
Yes, you have to keep dividing
Okay.
and multiplying on the reciprocal. But
Okay.
I'm not gonna go that far because I have a calculator that's gonna do all that work for me. And I'll show you that calculator in a minute here. So first off, these fractions, I wanna actually do some fraction conversions with you right now. So we saw those. I want to just start by going, say, for example, 1/2, and I want to make that into a decimal. What I do is I take my numerator and I divide it by my denominator. So the numerator divided by the denominator. So 1 divided by 2 comes out to 0.5. Yes? Pretty straightforward. It's pretty easy. A lot of people know intuitively that point or 1/2 is 0.5. Okay, we kind of know that already. So we'll do a couple of more here. If I had, say, 3 over 8 and I wanted to make that into a decimal, I would simply take 3 and divide it by 8. And that equals 0.375 as a decimal, correct? Like hopefully you have a calculator handy doing some of these things with me. So that's how you convert a fraction. So a fraction into a decimal is divide, right? Divide the numerator by the denominator. or I can't spell this morning. Okay, so we take the fraction into a decimal and divide. To do that, you take the numerator and divide it by the denominator. So it's just at the point where we take a decimal and we want to convert a decimal into a fraction. So the way to do that, or one way to do that, is simply put this number over 10. So we could just count how many decimals we have. We have one decimal, so that's going to be over 10. So what we do is we take 5 and put it over 10, because one decimal would be that. So we just count how many decimal places, and we will put the number 1 under it, and then we'll add zeros for the number of places it is. So 0.5 comes out to 5 over 10, and then we could reduce that further. We know that 5 over 10 is a half. Let me describe that again to you. For example, if I had a decimal of 0.125, I could simply put 125, and I count how many decimal places there is. There is 1, 2, 3. So 1, 2, 3. I simply put 125 over 1,000. And then I could reduce this down all the way. Well, if I divide it by 5, divide it by 5, divide it by 5, I'm going to get all the way down to 1/8, believe it or not. So if I have, for example, 0.625, what I do here is then put this under 1, so 625, and I count my decimal places. 1, 2, 3, so 1, 2, 3. So this becomes 625 over 1,000. So it's 625 over 1,000. And that actually equals 5/8 if I reduce it down. Now I'm going to show you a different trick here. I'm going to stop sharing for a moment. And I'm going to go to my calculator. I'm going to have to move this over. All right. And I'm going to go to my calculator. Give me a second here as soon as I load this up. And I'm going to share this screen. Can everybody see my calculator? Yes?
Yep.
Excellent. So I'm going to clear that off. And I might have to write a couple of things on this paper. So we're going to do some of those same examples that we just did on the whiteboard there. Okay. So I'm going to go all the way and start doing some adding of these fractions. So can everybody see this little ABC button here? That's probably not a good pointer. Can you see the ABC button that I have here on my calculator? Yeah. That button is my fraction button. Let me just zoom in a little bit more. There we go. That button is my fraction button. So the very first one that I told you, I said a half plus 1/2. So to type that into my calculator, I'm going to hit the 1 button. You see that? And then I'm going to hit my ABC button right there, that ABC button to start my fraction, and then 2. So on my calculator right now, that is a half. And then I'm going to hit the plus button, And I'm gonna do it again. 1, ABC button, 2, and I hit the equal sign, and look, that equals 1. Half plus a half is equal to 1. Now, the next question that I did by hand when I was talking about it is I said 1/4 plus 1/2. So on the calculator, I don't have to do any, I always got a chat here. Yes, Kristen, there is. Okay, and I'll get there in a second. So I'm going to take my 1/4, 1, hit my ABC button, quarter. There's 1/4. I'm going to hit plus 1, ABC button, half. Hit the equal sign. Look at that. That equals 3/4. I don't have to do any common denominator. The calculator does all the work for me. So clear that off. The next one that we did is I said subtraction is 1/2, and I believe I said 1/5. So we had 1/2 minus 1/5. I'm going to do that on my calculator. I go 1 ABC button, 2 minus 1 ABC button, 5. Hit the equal sign. That is equal to 3/10. Pretty cool. We're going to let the calculator do a lot of the work for us. So now we had some mixed numbers. I went as far as going 1 1/4 minus 3/8. And so to do that in the calculator, we're going to type in 1. We're going to hit the ABC button. We're going to say 1 again, ABC button, and the 4. That's how 1 1/4 is going to look on the calculator, just like that. And then I hit my minus 3 ABC button, 8. And I hit the equal sign, and look at that. That equals 7/8. So that's how that works with mixed numbers. So we're going to go over and we're going to do some of these examples of multiplying those fractions using the calculator. And I'm going to use the same examples that we used on the whiteboard. Well, let me just move this out of the way. We're going to do some multiplying. So let me just put that up there. I think I need a thinner Sharpie because that is a little too thick. I need something with a very sharp point. Okay, so I'm going to use a different marker. So multiplying fractions. So we did the example of 3/5 and we times it by 1/2. So again, using your calculator, 3 ABC 5 times 1 ABC 2. And of course, that comes out to 3/10. As you can see, that's how to read the calculator. Thanks for that, Alex. You know, parts of me are very nice. The rest, not so much, but yeah. So that's the start. I'm just going to go through a couple of things. We're going to get to the dividing feature before I pause for the break. I know we're close to the break here, so just bear with me. I'm almost done with this. Let's do the other couple of examples that we have. So we had one example that said 1/4, and we multiplied by 1/2, and we multiplied that by 3/8. So let's do that one. So 1 ABC 4 times 1 ABC 2 times 3 ABC 8. equals, look at that, 3/64. The calculator reduces everything down to its lowest common denominator, so I don't have to reduce it any farther. That's why I like the calculator. That's why I want you to have one, because I want this calculator to do all of the darn work. So the next example that I showed you was 2 1/8 times 3/8. So let's do that. So that's 2 ABC, 1 ABC, 8. There's 2 1/8 on my calculator, and I multiply by 3 ABC, 8. And that comes out to 51/64. And I believe that's the answer we had when we did it. And now just a couple of dividing ones. Very similar. Our first example was 1/3 divided by a half. So again, 1 ABC 3 divided by 1 ABC 2 is equal to 2/3. Pretty straightforward. Now I'm going to do the very last one that I did, which was 1/4 divided by 1/5. So let's do that one. 1 ABC 4 divided by 1 ABC 5. That comes out to 1 1/4 is how you write that particular one. So that in itself is how to use the calculator. So far, we're going to do more. We're going to convert decimals into fractions, etc. So having said that, let's take 15 minutes, get up, stretch your legs, get something to drink, get something to, take the cat for a quick walk, whatever it is, and we'll come back here at 9:05. Okay, as we get back into this, we're going to go over how to convert decimals back to fractions with the calculator. So I'm going to share this screen here to start. Now, if I had any kind of decimal, I can convert it back into a fraction. If any decimal ends with a 0 or a 5, if any decimal ends with a 5 or a 0, what we do is we do the 5 and then we count how many decimals it's through. So we put a 1 there, it's 1 decimal, so 5/10. Now in the calculator, we can go 5, ABC button, 10, and we can hit the equal sign and it comes to a half. So that's how you convert a decimal back into a fraction. And this is only with ending in 5 or 0. Okay, that's the only time this is going to work. I'll show you a different way in a minute. So if I had, for example, 0.125, I take the 125, put it over 1, count my decimal places, 1, 2, 3, 3 zeros. So in my calculator, I go 1, 2, 5, ABC, 3 zeros. That's how it looks there. Hit the equals button, and it reduces it down to 1/8. Pretty straightforward. I'll do another couple of examples of this. So if I had 0.625, look, this ends in 5, so I can actually go 625, put it over 1, count how many decimals, 1, 2, 3, and I go to my calculator, I go 625 ABC, 1, 2, 3, hit the equals button. It comes out to 5/8. So this is when fractions end in a 5 or a 0. This way does work. Now, when we want to convert decimals, and when the decimals don't end in 5 and we want to convert it to fractions, this is the way to do it. So, for example, if I had 0.75, we know that that ends in 5, but I'm going to show you a different way of how to do this. So if I wanted my denominator to be 4, I simply take my decimal and I multiply it by the denominator. The answer is my numerator. So again, this is the denominator. And when I multiply it by my decimal, the answer ends up being the numerator. And I do it like that. So let's do another example of that. If I had I'm going to use some of the same numbers, 625, and I want my denominator to be 8. I simply multiply my decimal by 8. And if I do that on my calculator, 0.625 times 8, it comes out to 5. My numerator is 5. Pretty cool there. That's a great question, Kristen. How do I know what my denominator is going to be? I will tell you in a question. I will say, take that decimal and reduce it to 1/16 of an inch. And that's how I'm going to do that. So I will let you know what you need to reduce it down to. Okay, thank you.
Hey, Doug,
Yes, sir.
can you show me how you did that on the calculator for the last lesson, only ending in 5 or 0?
Sure, you bet.
How you put that in the calculator.
Sure, you bet. So again, here, I'm gonna just put it right beside the calculator. So if I had an example of 625,
yeah,
and I wanted to put that in the calculator, first I put the 625 over 1, and then I count how many decimals it is. So there's 1, 2, 3, so 3 zeros. So I type 625 over 1,000 in my calculator. So 625 ABC 1,000, and then you just hit the equals button.
Oh,
and
perfect.
It reduces it down to 5/8.
Sweet, thanks.
Okay, no problem. So let's do a couple of more examples taking decimals. For example, if I had 0.133 and I wanted to convert 0.133 into a fraction to the nearest 16th. So what I do is I take 0.133 and times it by my denominator. And the answer is my numerator. Now we round up, we round down all the time. This is going to be 2/16, which actually reduces down to 1/8. So we round up and round down. Let's do another couple of examples on this. And if I had, for example, 0.894 as a decimal, and I wanted that to the nearest 8th, I simply take my decimal and times it by 8 of my denominator. So I'm going to go 0.894 times that by 8, and it comes out to 7.15. So we round up, round down, that's going to equal 7/8. So that's a quick, why are we rounding fractions, Kristen? We're rounding the answer to get it to the fraction. This is a loose kind of base, and this is how I want you to take decimals and convert it back to fractions. I understand what you're trying to say, but 0.15 of an eighth, it's very small. It's really not applicable to a tape measure, is it? So if we want to convert that to a tape measure, we're going to be close enough on that particular thing. So accuracy in that regard, I understand what you're trying to say. We're just not going to be that particular.
So
Yeah, we're not
we
using
would need to
micrometers.
be absolutely tiny measurements for the fractions to be worthwhile.
That's right. So if you could see my ruler here, you can see my ruler down here. When we're talking about 1/8 of an inch, that's how much an eighth is, right? So if we're talking about 0.15 of an eighth, that's even like millimeter size. I can't do that on a tape measure. So let's actually do some imperial measurements around fractions, okay? So it's a good lead off, actually, Kristen, so thank you, because we're going to lead off into something here. So if I had 6 inches, nope, you're not going to see that, 6 inches, and I wanted to make 6 inches into a fraction of a foot, look, I have to divide 6 inches by 12 inches per foot, yes? And that would equal 0.5 feet. So 6 inches is equal to 1/2 foot. Does that make sense to people? It does, right? It's 1/2 foot. So this is where it gets a little, I guess, a little more complicated. So if I said 7 inches, 7.35 inches, let me rewrite that again, 7.35 inches, and I wanted that broken down to the nearest 16th of an inch. So we're going to get decimal of inches all the time. And I want to convert it to something that I can measure on my measuring tape or ruler. So 7.35 inches, I'm going to take my 0.35, my decimal of an inch, and I'm going to multiply it by the denominator I want that to be. And that equals 5.6. Now, in this case, when my decimal is greater, 5 or greater, we round up, and that's going to be 6. So that is going to end up being 7 6/16. 6/16 we can reduce down to divide the whole thing by 2, and that's going to be 3/8. So my answer, 7.35 inches, is equal to 7 3/8 inches, and that is close enough for us as we're talking about fractions of inches. I think we need to do a few more of those examples. So let's make it a little more difficult. Now, I want to kind of get back to my whiteboard, but this is okay for now. So if I had 2.45 feet, And I want to take that decimal of a foot and I want to convert it into feet, inches, and to the nearest eighth of an inch. So I want to convert this into feet, inches, and eighth of an inch. So 2 feet remains by itself. I can't change that into anything else. But I'm going to take my 0.45 feet and I'm going to convert that into inches.
2.5.
And I, yes,
Oh, sorry. Thought I was on mute.
the assignment I uploaded has the answers. Not the test, I hope.
Assignment, yeah, 1.5.
Oh, that's awesome, eh?
Yeah.
Well, there. That's hilarious. Thank you for that. Okay, I just hid it from view. Anyways. Okay, so we're at 0.45 of a feet. I have to multiply that by 12 inches per foot to get it back into inches. So 0.45 times 12, that's going to be 5.4 inches. So that's going to be 2 feet 5. Now I take my 0.4 of an inch, and I said I wanted that to the nearest eighths. So I multiply my 0.4 times that by 8. That gives me 3.2. So that's 3/8. So inches. So 2.45 feet is equal to 2 feet 5 and 3/8 inches. And are you tisking me? I guess, eh? Is that what that is? Tisk.
No, him.
Oh,
I'm
well,
telling you.
well, listen, you're just making me homesick. That's all. And, you know, it's what happens here all the time in my house. Make mistakes. Anyways, yeah, that's what it is. All right, so let's do some more examples on converting feet and decimal feet back into fractions. Okay. Let's do a new one here. So I'm going to clear off my calculator. I'm going to say take 37.85 inches, and I want you to convert that into feet, inches, and to the nearest quarter of an inch. Okay, so we need to take 37.85 inches and convert it into feet, inches, and quarters of inches. So listen, I know that there is 12 inches per foot. I know that already. And I know that 36 inches is equal to 3 feet. I mean, I just know that in my brain. I don't know why I know that, but I just do. So if I minus 36 inches or 3 feet off of this, that's 1.85 inches. So that's 3 feet. So I already have 3 feet. And I already have 1 inch. So now I have the 0.85. And I wanted it to quarters. So 0.85 times 4, that equals 3.4. So that's going to be 3. There's my answer. So 37.85 inches is equal to 3 foot 1 3/4 inches. So that's converting feet and inches into inches and feet and fractions of inches. And I think we could do a couple of more examples of that. I think we need lots of examples of these ones, because they're going to be more important to us as we move through some of this stuff. Okay, let's do another example. I want you to convert I want you to convert 720.799 inches to feet, inches, and to the nearest 16th. So take a minute and convert that. Does anybody have an answer? Yeah? No? Yeah? What do you got, Alex?
I've got 60 feet and 0 and 13/16.
13/16? Okay.
Yeah.
So what we do is we could take the 720 inches and divide it by 12 inches per foot. So if I divide this by 12 inches per foot, yes, that turns out to be 60 feet. So I have 60 feet, and now I have 0.799 of an inch. And I said I wanted that converted to the nearest 16th. We take 0.799 times by the denominator that I choose. And that comes up to 12.78. And I round this up to 13. And that is right, 13/16 inches. I have 60 feet and 13/16 inches. Pretty good. Well done, Alex. Okay, so that's kind of crazy stuff. And this is the kind of thing that we're going to be doing. So let me stop sharing this for a second. I am going to actually go back to my whiteboard, and we're going to do a couple of the, let me just get organized here. We're going to do a couple of these together out of the ILM, okay? So let me share this screen with you. So now you can see I have my ILM here, yes? Does everybody see the ILM? Right there. I'm on page 26.
It's page 28 for anyone who has
Page-
a physical ILM.
Page 28 for you. Okay, so I think we know how to do these to decimals. I think we know how to do that. I think we've done a few of those examples. Now, these ones right here is convert the decimals to exact common fractions. So we could see that we could put the 6875 right? And then we put it over 1, and then we count how many decimals we have. We have 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. And I'm going to type that into my calculator. I'm going to go 6875 ABC button 10,000. And that should come out to, well, I can't quite call it inches yet because I don't know that. Okay, 11/16. Is that what you got for that first one? Yeah, pretty sure. Okay, so the second one, 0.75, I don't even have to, I know this intuitively. I don't know why. Now, 0.8125, again, 8125, put it over 1, count how many decimals you have. 1, 2, 3, 4. So 1, 2, 3, 4. So that's going to be 8125. And that equals 13/16, yes? Pretty good. Now this one here, I go 875, put it over 1, count how many decimals, 1, 2, 3. So it's 875 over 1,000. And that is 7/8. Good, huh? Pretty easy stuff so far. Now, we have these decimal of inches. So this one, they don't end in a 5 or a 0, so it's harder to do. So what we do, if it's a decimal of an inch, we simply take our decimal of an inch, 0.84, and times it by whatever I want my denominator to be. So we're going to times that by 8. So 0.484 times it by 8, it comes out to 3.8, and that rounds up to 4/8, and that comes out to a 1/2 inch. So 0.484 is close to a 0.5. It's really close. And to measure that on a tape measure, it's going to be close to a 1/2 inch. If I had a journeyman that said, please cut me a piece of pipe 0.02 of an inch, that tape measure is going to go at rocket speed at his head. I'm going to be throwing my tape measure at him because there's no way I'm cutting anything that close. There's no way. Not the way Matt's cutting up his breakfast. I mean, there's no way I'm doing any of that. That's too close. Then he turns off his camera. Awesome. Okay, so the next one here is 1.93 feet. 1 feet always stays by itself. I can't convert feet, but I have to take the 0.93 and times it by 12 inches per foot, yes, to get it to inches. So 0.93 times 12 is equal to 11.16. So that's 1 foot 11. And now I have the 0.16 and I want it to the nearest 16th. So I take the 0.16 times it by 16. And that comes up to 2.56. We round that up to 3. And then that is 1 foot 11 and 3/16 inches is how to convert that. Okay, one more. I'm going to do this one right here, 7.59 feet. So 7 feet stays by itself. 0.59 feet. We multiply that by 12 inches per foot to get it to inches. And that's going to be 7.08 inches. So that's 7 feet 7. Now the 0.08, I want it to the nearest eighths. So we take 0.08 times it by 8. is 0.64, and we round that up. It's greater than a half, so we round it up to 1/8. So 7.59 feet is equal to 7 feet, 7 1/8 inches. Pretty straightforward, I hope. Is there any questions around this stuff before I keep moving on? Everybody's okay? Everybody's good? All right. So let's do number 16 right here. Number 16 out of this ILM right here. We have a 10-foot piece of pipe, okay? We cut it to 7 equal pieces. How long is each piece of pipe? So 10 feet, and we want to divide that by 7 pieces. So simply 10 divided by 7 is equal to 1.43 feet. I'm going to round that second decimal up. That's all I did there. So it's 1.43 feet, but they want the answer in feet, inches to the nearest eighth. So 1 foot stays by itself. I'm taking the 0.43 feet, multiply it by 12 inches per foot to get it to inches. And that comes out to 5.14 inches. So that is 1 foot, 5. Now I take the 0.14 inches times it by 8, my denominator. And that comes out to 1.1. So that becomes 1/8 inches. So there's my answer for number 16. We got that? Cool.
I've actually got a question about that.
Sure.
'Cause when I was doing the 40.43 feet, I got 5.16 instead.
Okay, I just rounded up, so it's close enough. Okay? It's just the rounding issue, that's all. Thank you for that.
Okay.
Okay. Okay, number 17 on this list. This is probably one of the hardest questions. Nick, you know this question, I think.
Probably not.
Well, we did it yesterday, remember?
Oh, yeah.
Yeah, okay. All right, so number 17, it's a pretty hard question, in my opinion. So here we go. Let me just, okay. So we have a 9-foot piece. This 9-foot long pipe is, if we cut it into 6 pieces, 5 pieces are the same length and 1 is half as long. What is the length of each long piece and the length of the short piece? Answer in feet and inches to the nearest eighth. So let me just draw a picture. So I have a piece of pipe. That's a terrible picture. 9 feet long. Okay, I have a piece of pipe that's 9 feet long. Yeah. And I need 6 pieces. So 1, 2, 3, 4, 5. So there's 1, 2, 3, 4, 5, 6 pieces. But one of these pieces is just half as long as the others. So I'm going to take all these pieces and I'm going to cut them in half, the long pieces. So I'm going to cut them in half to make a bunch of halves. And then I'm going to count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. I actually have 11 pieces that are halves. So I have 11 halves here. So now what I can do is I can take my 9-foot piece and simply divide it by 11 pieces. And that's going to be the half as long ones. So I'm going to take 9 divided by 11. That comes out to 0.818 feet. This is the length of the half as long one. That's the length of the half as long one. So let's convert that into feet, inches to the nearest 8. So 0.818 feet. And if I times that by 12 inches per foot, I'm going to come out to 9.818 inches. But here I want to convert this into 8. So that's going to be 9 inches. And I'm going to take my 0.818 and I want that into 8 times that by 8. And that's going to be like 6.5 something. So I round that up to 7/8. There is my half piece, 9 7/8. So now I could take 9 7/8 inches and simply times that by 2. And I could type that right in my calculator by going 9 ABC button, 7 ABC button, 8, and times it by 2. And it comes out to 19 3/4 inches. But that still isn't the correct answer because I want it in feet. But I know there's 12 inches per foot. So I could say that 1 foot, 7 3/4 inches is the long piece. Kind of crazy, huh?
Yeah, I'm confused.
Are you?
I will say I am too.
Okay. Well,
How-
me too.
1.
okay,
Yeah, I
so
got
let's
lost as
go
well.
back. Let's go back at the question then. So there's a 9-foot long pipe and we want to cut it into 6 pieces. But 5 pieces are the same length and 1 is half as long. So what I did is I had my 9-foot piece and I made 6 pieces, but one of them is half as long as the others. So I just made a whole pile of halves. So 5 pieces cut in half make 10 pieces plus the 1/2. So I ended up with 11 pieces right here. And that's why I ended up taking the 9, dividing it by 11. And that equals 1 of the half pieces. Hopefully that helps. I don't know. This is it is a hard question. That's why I'm going over it. It's one of the harder questions in the book. I'm sorry, Bay. I just saw your cat walking by. Yeah,
See,
started
like, I understand like the work that we did. I'm just confused how we got 19 3/4 down to 1 foot and 7 inches.
Oh, well, 19 inches is
Oh yeah, sorry. I didn't
1
realize-
foot 7.
Yeah, we were
That's
still.
19 inches, yeah? Okay,
Yeah.
I made the leap. I jumped. I just, okay.
Yeah, no, that makes sense. I just forgot that we were still working in inches, not feet.
Yeah, and that's important. We have to know increments of measure, don't we? Increments of measure becomes extremely important. Sorry, got a notice about my phone bill. I hate paying my cell bill. Man, it drives me nuts. Just, I hate paying that freaking thing. So did everybody catch up? Are we close? Let's do the next one. Let's do number 18. So number 18 on here says we have a spool. A spool, if you did not know, is kind of a piping arrangement that we make. Our pipe fitter people would know that, maybe a little bit more than the plumbers or even the sprinkler fitters, but that's okay. So that's what a spool is. It's a piping arrangement. So we have 7 T's on here, and they're equally spaced from each other from the flanges on the ends of the spool. So we have a flange, and then we have a piece of pipe in between, and we have a flange. That's what it says. So if the total length, so my total length here is 37 feet 6 inches, right? This is the total length. And I need 7 T's. What is the spacing of the T's? And we want the answer in feet and inches to the nearest eighth. So listen, I'm going to put my T's in here. 1, 2, 3, 4, 5, 6, 7 T's. I know that looks ugly, but really what I'm trying to get to is how many spaces there are in between. So that's 1, 2, 3, 4, 5, 6, 7. There's 8 spaces in between this. So I could take my 37 feet 6 inches and divide it by 8 spaces. Excuse me. But wait a second. What we have here is I have 2 different increments of measure in the equation. I cannot multiply, divide anytime I have 2 different increments of measure. It's one of those things that we have to make this 37 feet into all feet, or I make it into all inches. I cannot divide 2 dissimilar increments of measure. So now I have 37.5 feet. Do you see how I changed my 6 inches into a decimal of foot? I just made that leap. I didn't do any math there. I just said 6 inches is equal to 0.5 feet. Hopefully you can understand that. And now I could take that and divide it by 8 different pieces. And that comes out to 4.6875 feet is my spaces in between my T's. So 4 feet remains the same. I know I'm running out of space here. Let me just move this up a little bit. I'm going to take that 37.5 feet, move it over here. So 37.5 feet, and I divided that by 8, came out to 4.6875 feet. Now I got to convert that into inches and fractions of an inch to the nearest eighth. So 4 feet remains the same. I'm going to have 0.6875 times it by 12 inches per foot. Is equal to 8.25 inches. So that's 4 feet 8. And I wanted that to the nearest, well, 0.25 of an inch. Can anybody just guess what 0.25 is as a fraction?
Quarter of an inch.
It's a
Yeah.
quarter. 0.25 of an inch is a quarter. Now we could do that. We could times this by 8, and that's going to come out to 2. So that's going to be 2/8, and that reduces down to 1/4. So for that question, the answer is this: 4 and 8 1/4 is the spacing between tees.
Do you think you could do that again, but instead of converting all of that to feet, do it in all inches? And see
Sure,
what
let's do that. We'll do it in inches, and then we'll take a break. So we'll do this one just in inches, and we'll take a break. So that was 36 feet 6 inches. And if I convert that into feet, or inches, sorry. So
It was
36 feet
I think it was-
times 12
was 30.
inches per foot.
37 by 6, wasn't it?
Yeah,
Oh, 37. Oops.
Yep.
Sorry, let me just change that. Change that. 37 feet. 30. Okay, that's 37 feet 6 inches. So I'm going to take the 37 feet times it by 12. I'm going to get 444 inches, and I'm going to add 6 inches to that. So I have a total of 450 inches, correct? Is 37 feet 6 inches is equal to 450 inches. Now I'll simply divide that by 8 spaces. Which is equal to 56.25 inches. Yes? That's how much space is in between each tee. So now, if I go 56.25 inches and I want to convert that back to feet, I can simply divide by 12 inches per foot. And that's going to give me 4.6875 feet. So having said that, that goes to 4 feet. And now I have the 0.6875 feet times by 12 inches per foot to get it back into inches. And so that's going to equal 8.25 inches. So that's 4 feet 8, and then 0.25 inches to the nearest 1/8 of an inch is equal to 2/8, or if I put that to its lowest terms, that's going to be 4 feet 8 1/4 inches. And that's how to do it with the inches part. We are going to do a few more examples right out of the ILMs before you get to the answer key that's on D2L. Sorry, I shouldn't have said that. But so please, let's take a break. Let's see if I can stop this recording or pause it. I'm going to pause the recording. Okay, I'm going to share my screen, and I'm going to go back to my whiteboard somewhere. Let me just find it. I get confused. I don't know what I'm doing half the time. So I'm going to share my whiteboard again. There you are. Let me zoom out. Look at all the work we've done so far. I've drawn all over this stuff. As you can see, we could keep it as a record. I could actually email this board out to you if you wanted me to, but we also record it so you can see it as well. So I'm going to talk about a couple of different increments of measure before we continue on with some stuff. When I need to talk about some metric right now. We've been focusing on imperial measure, but I need to talk a little bit about metric. So 1 meter, oh man, I cannot draw today. So 1 meter, let me just be a little more. Does anybody know how many millimeters in a meter? Anybody? Anybody? No? Nobody knows?
1,000.
1,000. There is 1,000 millimeters in a meter. Now, in 1 meter, there is also 100 centimeters. Yes? And in 1 centimeter, there's 10 millimeters. Yeah? So these are some of the conversions, if you will, or numbers that you need to know. Now, when we're talking about metric, or for that matter, feet and inches, when we are, say, multiplying meters, so if I had 1 meter and I had to multiply by 200 centimeters, we cannot do this because of the increments of measure. I have centimeters and I have meters. I can't multiply those together. So we have to convert one to the other. Okay, so what I can do is I always want to go to the larger one on this, especially when we're talking about centimeters and millimeters, and I'll tell you why in a minute. So 200 centimeters, I know that there is 100 centimeters in a meter, so I'm going to divide by, well, here we go, 100 centimeters in a meter, and so that's going to equal 2 meters, yes? 200 centimeters is equal to 2 meters, so I can go 1 meter times 2 meters is equal to, so 1 times 2 is equal to 2. But here, look at this, I have 1, 2, so this becomes meters squared. Yes? When we take meters and we times it by meters, it's going to equal square meters. Let me just convert all of this equation into centimeters. So 1 meter is equal to 100 centimeters. So I'm going to go 100 centimeters and multiply it by 200 centimeters. And that comes out to 20,000 centimeters squared. You see how it's centimeters times centimeters gets me square centimeters. Now, that number is starting to get pretty darn big, isn't it? Like 20,000 centimeters squared in 2 square meters. So if I convert this equation that I got here into millimeters, so that's going to be 1,000 millimeters times 2,000 millimeters. Sorry, this should be millimeters. It's 2,000 millimeters equals, now whew, 1, 2, 3, 4, 5, 6, 7 millimeters squared. You could see that this is getting out of hand really quickly, yes, with these large numbers. So anytime you're multiplying metric numbers by each other, try to convert to meters. Always try to go to the larger numbers first, because these numbers get out of control and I can't even fit them in my calculator.
I mean, you got to zero too much in there, just if anybody wants to reference it later.
Okay, well, look at, I could remove it. There you go. Thank you for that. Glad somebody's paying attention. I can't afford to pay attention. I don't get paid much to do this job, so I can't really, you know. All right, so that's kind of a little bit of a metric conversion, but I need to start talking about feet and inches again. So anytime, so this is now feet and inches again. So for example, if I had 7 feet, 6 inches, and I wanted to multiply that by 8 feet, 3 inches. Now I have a bunch of dissimilar increments of measure here. So I will need to convert my inches into feet. So to do that, I simply have to take my 6 inches and convert it into feet. I divide by 12 inches per foot. So 6 inches is equal to 0.5 feet. So that comes 7.5 feet. And now I have to convert my 3 inches into feet. So 3 inches divided by 12 inches per foot is equal to 0.25 feet. So now that is 8.25 feet. Now, and only now, I can do the operation because I have the same increments of measure across the multiplication. So I can go 7.5 and multiplied by 8.25. And this equation equals 61.875 feet squared. I cannot fractionalize or make this a fraction. This square feet is square feet. It's going to have a decimal and it remains a decimal. I can't make a square feet into a fraction. It has to stay as a decimal. So let's do that same one and let's do it in inches, okay? So I'm going to take this equation, 7.5 feet times, oh, sorry. Let me get back here. Let me just make that mistake here. 7 feet, 6 inches times 8 feet, 3 inches. And I'm going to convert all of this into inches. So 7 times 12, so 7 feet times 12 inches per foot is going to get me a number. 7 times 12, I should know this, is 84. And I have to add the 6 to it to make it all inches. So 7 foot 6 inches is equal to 90 inches. So now I'm going to convert the 8 foot 3 inches and all into inches. So that's going to be 8 foot times 12 inches per foot. That's going to be 96. And I add 3 to it. So this is going to be 99 inches. Now I can multiply those together. 90 times 99 is equal to 8910 inches squared. Now I can't convert that anymore right now. So keep this number in mind. Now I want to convert that back into square feet, and I can do that by knowing how many square inches in a square foot. So for example, if I had a square foot, that was 12 inches by 12 inches, or 1 foot by 1 foot. So 12 times 12 is 144 inches squared, is it not? And I could take 1 foot times 1 foot is equal to a square foot. So here is the big reveal that there is 144 inches squared in every square foot. Right there, that number right there. 144 inches squared in a square foot. Now I have 8,910 inches squared. And if I want to convert that into square feet, I will simply divide by 144 inches squared in a square foot. As you can see, we are dividing out the square inches. I'm left with square feet, and that comes out to 61.875 feet squared. Kristen, your question. As you can see, I took my 7 foot 6 inches right here and I made it 7.5 feet. That's why the inches are gone. I made the 8.3 inches into 8.25 feet. That's why the inches are gone. And when you take feet times feet, it equals to square feet. Does that answer your question? I hope. No, it doesn't. When you write your final answer, it is in square feet only. So when you go feet times feet, it's square feet. There's no inches left because we're in a squared position. It's either going to be in fully square inches or it's going to be in fully square feet, the answers. They're never going to
I
be.
think I'm not communicating well with you.
Okay.
So my question is why you've gone from writing the annotation with the quote marks to writing inches, like IN.
Well,
Why
because
can't I just put quote marks squared?
yes, I understand what you, okay, I see what you're saying. So if you want to go like for this one, 8910 inches squared, is that what you're asking? So to me, that kind of, I write the IN instead of this little inches indicator because it's a little easier to understand. Okay, instead of that, and that. I write it like this. Okay, it's just a little, geez. It's just easier to understand for me. So inches squared, so I can see it, right? That's why. Sometimes making the annotation inches squared or feet squared, it's not, it kind of gives you the idea that there's something there that's not. So that's why I do it, okay? But thank you, Jen, the same. I do that because if your annotations or annotations of the feet is longer than that, it looks like a 12. So that's when I write it, and then I go like this. I go feet squared. Ooh, I'm erasing stuff. There we go. So that's why I go feet squared instead of feet squared, because it doesn't sometimes transfer across very well. Hopefully that answers the question. Awesome. Everything is awesome. Yeah. So let's go back and let's do a couple of these right here. Okay, if we look at number 27. Oop, dragging my pen around. We look at number 27. Right here. It's take 7 foot 6 inches and divide by 15. So clearly we have 2 increments of measure here that we have to convert either or into inches or to feet. I like to go to the larger numbers. So I'm going to take 7.5 feet and I'm going to divide that by 15. And that comes out to 0.5 feet. Or we could say that is 6 inches, couldn't we?
Yep.
Yeah. So let's go to number 28. It says divide 4 foot 6 inches by 9 inches. Now we could do a couple of different ways. We can convert it all to inches, or we can convert it all to feet. Let's do both. 4 feet, 4 times 12 inches per foot is equal to 48 inches, and I add 6 to that, that's 54 inches. So that's going to be 54 inches divided by 9 inches.
6.
And that equals 6 inches. If we convert it all to feet, that is going to be 4.5 feet. And now I have to go 9 inches divided by 12 inches per foot. I think that is 0.75 feet. So 4.5 divided by 0.75 feet is equal to 0.5 feet. So herein lies the importance of having the increments of measure equal on either side of the multiplier divide, or whatever you're putting together, have the same increments of measure. You can't have 2 dissimilar measurements to multiply or divide. And that goes with metric or imperial. It's just one of those regular rules. Okay. So that kind of brings us or leads us into some perimeters and areas. So as you know, I don't want to do that. As you know, when we take feet times feet, we get square feet. So this is bringing us into some surface area stuff in square feet. Now, I'm going to go over some stuff with you next week on perimeters and areas, and then we're going to get into perimeters, areas, percentages, and grades eventually. But here we go. So this number 35 here is a surface area of a box. So this box clearly has an open top. So this is a box just like this, right? But it's got an open top. So that's why we do, or does it? No, it doesn't. This is a totally closed box that they got here. Okay. So we want the surface area, and how we want to have the area. Anytime you see area in an equation, you know it's going to be in feet squared or inches squared or meters squared. It's always going to be in a square situation when you see the word area. Always, always, always area comes out in squared something. So this particular surface area formula is right here for us. So it says length times width times 2 times length times height, 2 times width times height, add them all together. So these are our numbers. We're going to convert these all into feet because they want the answer in square feet. So 8 feet stays by itself, and 4 foot 3 inches comes out to 4.25 feet. 10 divided by 12 is 8.333 repeating. So this is going to be 3.833 feet. So there's my conversions. That's 8 feet, 4.25 feet, 3.833 feet. So that's all of these numbers right here. So now I can write out the equation by going 2 times, and first off, I'm going to go 8 times 4.25, and I'm going to add 2 times, and I'm going to go 8 times 3.833, and then I go add 2 times, and that's going to be 4.25 times 3.833. So there's how I write that out, and I will do the math in each of those brackets first. So 8 times 4.25 equals 34 times 2. So this equals 68. Ooh, where's my, I gotta move this down a little bit. Oh, I want to move it here. Move this down a little bit. This is equal to 68 feet squared. This one, 8 times 3.833 times 2. This one equals to 61.328 feet squared. And this one is equal to 32.58 feet squared. And we add those together. And we get a total of 161.91 feet squared is the answer for number 35. Kristen, can you expand on what you're trying to say there in the chat?
So like I said, it might be trivial, but for question 28, you were dividing a measurement by a measurement. So like, I mean, you converted it from feet and inches into just inches or feet.
Right.
But then your final answer you gave us was in inches or feet.
Right.
But I think it was just pieces. Like if you take 12 feet and you divide it by 6 feet, you're not left with 2 feet, you're left with 2 pieces.
I see what you mean. Yeah. Okay. Yeah.
Okay. Is that right? Am I right in thinking that?
Yeah, sort of. Yeah. Yeah, it is. Yeah. We're talking about pieces. Yeah. Okay. Now, that is that one there. So this one here, number 36. I want to do number 36 with you before we go. This is the last question or last example I'm going to do with you on this one here. So this question says an industrial hot water tank stands 10 foot high in height. Okay, so let me just draw a big hot tank. Yeah, I can't draw very well. So there we go. This is 10 foot 5 inches tall. Yeah.
Not to get out of control there, but that's not really an incomplete question, or it's an incomplete question. There's no thickness on the insulation.
Good question. We're going to assume that we are using a already predetermined insulation. I just want to know how many square feet I need, Richard. Does that make sense?
I guess.
Okay. Thanks for that. So we already have the insulation. We have a big roll of it at the warehouse or whatever, and I just want to know how many square feet I'm going to need. Okay. So thanks for that. I'm glad you're paying attention. This is really good. And this has a diameter of 4 foot 8 inches is the diameter of that tank. So anytime we do these equations, you're going to want to write down the formula. Okay. So this is totally enclosed. So that is 2 pi r squared plus pi diameter height. So clearly I have 2 dissimilar increments of measure here. So I'm going to make those measurements into feet first. So I take 5 inches, divide that by 12 inches per foot to convert that. 5 divided by 12 is equal to 0.4166 feet. So 10 foot 5 is my height, and it is now 10.4166 feet. My diameter, so I have to convert the 8 inches into feet. So 8 inches times 12 inches per foot. Oh, excuse me, divide. What did I just say times for? That's divide. Okay, pen divide by 12 inches per foot. And that is equal to 0.666 feet. So my diameter is now 4.666 feet. A radius, I never really talked about radius and diameter yet. So a radius is actually half of the diameter. So I have 4.66 as a diameter. I'm going to divide that by 2 to get my radius. My radius is 2.33 feet. So now I've written down my variables and I could put them into my formula. So I'm going to write it out here. So that is 2 times pi. So pi, this little integer there, is actually equal to 3.141592654738. No, let's hang on a second. Let's back up. We're going to use 3.1416 as a shortcut. On your calculator, the pi button, let me just show you right here. You see that EXP button right there on your calculator. The EXP button, if you look at the Zoom meeting, you can see my camera. That EXP button, if you hit it, that is your button on your calculator. That is the pi button.
Pi.
pi button on your calculator. The EXP button is the pi button. Or if you're typing it in, please use 3.1416 if you're typing it in to your phone or something. So that says 2 times pi times r squared. So 2 times pi, 3.1416, and multiply by r squared. So that's 2.33 squared. Now, I'm going to stop sharing for a second. And I want to reshare a different screen with you. Let me just pull this one up. So hold on to that thought for a second. So now you can see my calculator there. Can everybody see my calculator? Yeah. So I just told you, oh, let me just zoom out a little bit. There we go. I just told you that this EXP button is the pi button. So if I hit the EXP button, there's pi. So I'm going to type in that formula. So that was 2 times pi times 2.33. And this right up here is the square button right there. And I'm going to hit squared, and then I'm going to hit equals. So the first part of that equation, 2 pi r squared, is equal to 31.110. I just wanted to show you that button, the square button and the pi button on your calculator. And then I'm going to go back to my handy dandy whiteboard. So this equation over here is equal to 34.11 feet squared. The next part, we have to add 3.1416 multiplied by the diameter, which is 4.666, multiplied by the height, which is 10.4166. So pi times 4.66 times 10.4166. This is equal to 152.49 feet squared. Add these two together, 34.11, and that comes out to a grand total of 186.607 feet squared. And listen, if we're rounded up, rounded down slightly, that is going to be okay by me.
Square.
Wow, what a day.
With 152.49.
Sure, close enough. So now, I don't know what the Justin,
Okay.
well, Kristen, I made it pretty far. Are you talking about me? Or wonder how long I would have gone for?
Yeah.
Pretty sure it went bad after 265. I don't understand. Talk to me.
Oh, you got pretty
Relatively
far, but
long
I think
time.
some of the numbers got incorrect eventually. I think.
Did I? Oh, well.
I'm not positive.
Okay. So I have changed the assignment on D2L to not be the key, which is good. So you need to put your answers in the test area. Sydney, you got to do the test, not just submit the assignment.
I know I did it this morning, like right before class started. I did the test one.
Okay.
Sorry.
I was gonna tell you earlier, but it's okay. Thank you for that, though. I appreciate it. So do the assignment. It is due for next class, next math class, which is Monday morning. That next assignment, 1.5, is due. Now, let me just, oh, I can't do that. Okay. Let me just move this over. I'm going to share this screen again. I have you for a couple of more minutes. I'm going to put you over here. I'm going to zoom out. So we did some stuff today, clearly. Let's go back to the list that I wanted to talk about. Okay, so this is the list that we started with. And I think I talked about the calculator. We talked about adding and subtracting. We did some conversions. We did some of that. We talked about increments of measure. We did metric, a little bit of that. We talked about assignment 1.5. Now, extra work. I have a conversions sheet that you can do on the side if you want. I can post that on D2L in the announcements. And it's simply what it is just practice. Talking about practice, as Alan Iverson said, practice converting feet and inches and etc. into fractions and back and forth. Okay, it's just practice doing that. Now I will post that on the D2L announcements, but it is not mandatory and it's not going to be for marks. This is practice for you, not for me. And I will put it there and then I will post the key by next week. So then you can check your answers. The next class, everybody, please, this formula book thing in D2L under formulas, this is the formula triangle book. I would ask that you have it printed off. I'm kind of going to go through it, and I want you to have that when we do quizzes and tests. I want you to have that formula triangle booklet handy with you. So please print this off somewhere, somehow. You might have a friend somewhere, somehow, that'll print it for you. And this is the next ILM we're going to go over. 060205B is the next ILM that we're going to start. And that's perimeters and areas, percentage and grade, but we're only going to cover perimeters and areas. Is there any questions?
Yeah, could you go back to question 36 for a second?
Yep. And where's, oh, way down here. Yes. Whoa, I'm moving that all over.
So
Talk to me.
my only question really is what are we really rounding to? Because some of them you've rounded to 4 places, some of them you've rounded to 2 places, some of them to 3 places. Like there's
I
no
understand. I
consistency there.
understand.
So like my
If
answer was
I
off.
leave it on my calculator, Christian, I'm going
Yeah.
to have 12 decimals. So
Yeah.
let's make a point here. That's a good question. Let's make a point. Let's go 3 decimal places from now on. Okay,
Okay,
how's that?
sure. I'm
I
looking
was
at,
still gonna leave to a full pi and not a 3 decimal place pi, right?
Okay, and when we continue on, when we start doing volumes and capacities, et cetera, and more surface areas, and we're using pi, if our answers are this close together, I'm gonna call that good, all right? Now, you will know what the answer is according to D2L when you have to choose a multiple choice answer. You will know. Okay, as I'm doing math quickly with you guys and doing examples, and if I round off to 2, 3 decimal places, we're going to call that good enough. Okay,
okay, and then also, are you rounding to 3 decimal places, or in this instance, you're just dropping the rest?
I'm
Right.
kind of dropping some of them. This is
Okay,
what I'm
I just
doing.
wasn't sure of the consistency because I didn't know, like,
I
because
know.
my final answer was slightly different, and it would have been wrong if you're rounding to 1 decimal place. So I was like,
But if it's a multiple choice
Yeah.
answer, you will look at your multiple choice answers, you'll know which one to pick, right?
yeah,
Okay, thank you for that. I appreciate that.
thanks.
Any other questions, anybody? Well, again, thank you for participating in this crazy math. Let me stop sharing for a second. In this long-term math thing, I'm going to stop the recording.